In this question, we are given that a particle moves along the x-axis, and the velocity of the particle is given by function v of t, given explicitly to us. And we are also given that at time t equals 4, the position of the particle is x equal to 2. And the first question is, at time t equals 4, the question is whether the particle is speeding up or slowing down. And the way to answer that, we would need to look at velocity at time t equals 4 and get the sign of the velocity, and then acceleration at time equals 4 and also get the sign of acceleration. And so if both of those signs are either positive or negative, it means that the velocity is and acceleration move in the same direction, which means that the particle is speeding up. Otherwise, if the signs are different, then the particle is slowing down. And so let's use a calculator now to calculate the signs of those two variables. Let's plug in values into the function for the velocity t equals 4. And so this is 1 plus 2 times sine of t squared over 2, and t is 4, so 4 squared divided by 2, close parentheses, and this is our functional value. So we get a number 2.978, which means that the velocity is positive, which means that the particle at time t equals 4 moves to the right. Let's now look at the acceleration at that time. So let's go to mathematics. We need to look at derivative with respect to x of the function 1 plus 2 times sine of x squared over 2, close parentheses, and that is at x equal to 4. And so we can see here that the derivative of velocity is negative, which means that the speed is decreasing. The speed is decreasing. In this part of the question, we need to find all times t from the interval between 0 and 3 when the particle changes direction. And so first we would need to find all such times t that v of t is equal to 0, and then check whether at those time points the velocity changes direction. And so let's do that using the calculator. So let's find all t for which velocity is 0 between time equals to 0 and time equals to 3. So let's go to here and enter the function 1 plus 2 times sine of x squared divided by 2. Then let's go to window. Our window is from 0 to 3. And then let's graph this function. Find zeros for this function. And so we can see that on the interval from 0 to 3 there is 1 0 at which velocity changes from positive to negative. So particle moves to the right up to that point, and then it starts moving to the left. So let's find this point. Let's go back to window, and it looks like it's somewhere within 2.7 range, and so let's do 2.6 to 2.8, and then interval 0.1. Let's see, let's graph it. Yeah, so it's around 2.7. Let's go to trace and find x for which y is about 0. And so we can see it's about 2.71, 2.706. So the answer is 2.707. 2.707. In this question, we need to find the position of the particle at time t equals 0. And by the fundamental theorem of calculus, f of b equals to f of a plus the integral from a to b f prime of x dx. And so applying this formula here, we can see that f, in our case, is x at time 0 is equal to x at time 4 plus integral from 4 to 0 for the velocity v of t dt. And so plugging in those values, x at time 4 is 2 plus integral from 4 to 0 1 plus 2 sine t squared over 2 dt. And so we need to use a calculator to calculate that. Let's do that next. And note here, it doesn't matter here whether a is less than b or b is less than a, as long as this is the order f of a integral from a to b. So in this case it's integral from 4 to 0, or if we want to do it from 0 to 4, we need to change the sign here. So let's use a calculator next to calculate this expression. So let's calculate this expression. It's 2 plus integral, mathematics, integration from 4 to 0 of the function, and the function is 1 plus 2 times sine of x squared divided by 2 close parentheses dx. And so this should give us the position at time 0. So the position is negative 3.815 thousandths. So the position is to the left of the origin. In this part of the question, we need to find the total distance the particle traveled during the time between time 0 and 3. And notice that this is the total distance rather than displacement. So this is actually the integral from 0 to 3, integral of the speed rather than velocity. So it's absolute value of the velocity dt. So this is integral from 0 to 3, absolute value 1 plus 2 sine t squared over 2 close parentheses absolute value dt. And so let's use a calculator to calculate this value. So let's calculate this expression for the distance here. And so we go mathematics, integral. It's integral from 0 to 3. And we need to have absolute value of the velocity, which is 1 plus 2 times sine of x squared divided by 2 close parentheses, and this is with respect to x. And so we can see that the total distance traveled within the first 3 seconds is 5.301 thousandths. And so this is the distance traveled within the first 3 seconds. Thank you, and I will see you in the next video.